Today we're going to be discussing constructing lines of best fit. Students will be able to construct a line of best fit to accurately represent a set of bivariate data. A line of best fit can be used in bivariate data that have a linear association. And so what you're going to see on these scatter plots that we're looking at is that they essentially go in a straight direction. Either they are increasing or decreasing, or they're all staying the same. This line is also called a trend line, because it captures the trend of a scatter plot of data. So just like you have trends of what people wear, the music that everybody in your group listens to, the trend of a scatter plot, it shows essentially what's happening between all of the data points, but it's not an exact relationship. This line can help us describe the approximate relationship between the two variables and also helps us make predictions about the data. In this first example, students in an art class were learning to make realistic drawings of people. As part of their work, they investigated the relationship between height and arm span. They collected data from several individuals and made a scatter plot. Draw a line that best shows the trend of the data. So what I'm going to give you first are a couple of lines that would be incorrect. The thing about the line of best fit is we want it to kind of blend in with the points. We want it to show what majority of the points are doing. As I look at this, the points are going up and to the right. So if I were to draw a line that looked like this, that line is going down and to the right, and so that is not what my data is doing. Now, if I were to draw a line that's going up and to the right like this, even though it shows that increase as we move from left to right, it starts much higher than all of the data on the chart. And so that wouldn't be very good. What we want is to draw a line that's going to be within the set of data so that it clearly shows where the data is and also what it's doing. And so I'm going to start somewhere right around here. And my line is going to be straight because notice that everything kind of fits around it. Now, one of the goals of these is that you have about the same number of points on the top and bottom. So on the top, I have 1, 2, 3, 4, 5, 6 different coordinates being represented, and on the bottom, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it could be a little bit better. I could move that line down a little bit, but for the most part, that's a fairly decent representation of what all of the data points are doing. They're increasing as we move from left to right. The second example here, I have two different trend lines for the same 5 points. Paul has drawn a trend line on the left, and Joe has drawn a trend line on the right. I want you to think through whose trend line has a better fit for these data points. So thinking about you want the trend line to show majority of what's going on, so they're both going up and to the right. But I would say, in fact, that Paul's trend line is better because it shows where the data is. If you look at Paul's trend line, that line is in between a majority of the points. There's 2 on top, there's 2 on the bottom, and so it's kind of evenly split. And so it captures a picture of how high up the data points are plotted. It's not going to be exact, but it's definitely, it's almost like having an average or showing approximately where everything is. If I look at Joe's trend line, his is not very good because it's below all of the points. It's not even going through the data points at all. We want to see a line that is surrounded by our data points. So what I want you to do, take a minute here, and you're going to want to keep these ones up on the screen so you can kind of see the different colors. For each of the 4 sets of data, I want you to decide which is the best trend line. Which one best describes the data? Which one is surrounded the closest by the data that really shows the trend, whether it's increasing or decreasing? So make some decisions, either line 1, 2, or 3 for each piece. For this one here, what we're going to do is actually create the scatter plot, and then we're going to draw in a line of best fit and write an equation for it. A radio station tabulates the number of listeners when it reduces the time used for advertising. The results are shown in the table below. We're going to make advertising X and number of listeners Y. As I look at my minutes for advertising, it goes from 26 to 12, so I need to have at least space for 26 on my graph, so I need to label that. And then my number of listeners goes all the way up to 420, and so I need to label values for that as well. Okay, so take a second, make sure that your labels are the same as mine, and I'm going to plot those points for the scatter point. So when I played 26 minutes, so here's 25 right here, 26, I had about 240. Keep in mind a scatter plot's not going to be perfect. When I had 21 minutes, I had about 180 listeners, so that would be right about here. When I played only 18 minutes of commercials, we had 280. And 16 minutes was 300 listeners. And then when I had 14, so here's 15 right here, so a little bit before, I had 410 listeners. And then with 12 minutes, I had about 420. And so as I look at that, that's a pretty sharp decline. So I want to make sure that my line accurately represents that sharp decline. One way to help myself out, if I kind of circle in general the data, and then kind of draw a line through the middle of that circle. That will help me to see the best picture. Now that line isn't really through the center, so let me grab it again. I'm going to adjust. You're going to want to use a ruler and do the best adjusting that you can. So not too bad there. And then I'm going to get rid of that circle. Now, as I look at that, it's still not quite good. So a line of best fit is going to take a little bit of practice to make sure it's the best that it can be. So as I look at that, that's a pretty decent line of best fit. It's going to show me essentially what all of the data is showing me. And so we have our line of best fit. We have our scatter plot. We're going to write an equation, y equals mx plus b, to represent that line of best fit. What I'm going to do, because it's a line of best fit, it's going to be an approximation. And so it's okay to get a little bit of an estimate with your slope and your y-intercept here. So if I have 500 here, I know 550 is about here. And then 600 is about here. And if I were to extend that line backwards, that would hit just around 600 or 610. And so my y-intercept, I'm going to put at approximately 600 people. And then in order to determine my slope, I really want to try and find 2 points that are on the line, or 2 parts where my line goes through the grid lines of that graph. So I'm going to go with this coordinate here. And then really there's a couple of good places. Best place is going to be right here. So I'm going down 2 boxes, which represents 100, and then over one box, and that one box is representing 5. And so my slope would be negative 100 over 5. So y equals negative 100 over 5x plus 600. I could simplify that down to negative 20x plus 600. Now, if I think about that, this negative 100 represents listeners. And that 5 that's positive represents the adds. And so what that's telling me is that every increase of 5 minutes in ads, listeners drop by 100 people. And again, that's an approximation based on our line of best fit, but it is definitely clear that as the number of ads increase, the number of people decreases who are listening to the radio station there. All right, so you have one more you try in your note handout there. Your goal is to take and plot a scatter plot here to represent the SAT prep, and you're going to both create a scatter plot and write an equation of the line of best fit. So you'll have to draw your own line in, and we'll be talking about this more when we come back together.